Last part of this video, we'll cover importing the data into a product called Cyclone REGISTER 360. This is a newer product from Leica. It's designed to be able to take data from a field scanner. It works with all Leica scanners. In fact, it also works with some third-party scanners to bring it in and register if necessary, but also to be able to produce some sets of data. Now, REGISTER 360 is not designed to produce the final deliverable. It's just the intermediate step between the field and getting it to whatever design or modeling software that you're going to be using. In this case, we'll talk about Navisworks and some of the add-ons for it. I'll just create a new project in REGISTER 360 and give it a name. All right, what I'm going to end up with is a blank project. Now, there are a couple of options here to take a look at. I could actually load a background image. This is really helpful, especially for unregistered data, where you can bring in an image and actually move scan positions on top of a map or base map. In this case, with the RTC, for the most part, I don't really use this feature because the scans are already registered when I import them, which we'll see in a minute here. It's all designed to be drag and drop, very graphically, so it's a very graphical interface. I'll just go ahead and take a look at the USB drive and the contents. This is the USB drive directly from the RTC unit. And under this folder called RTC Store is this project folder. What I do is I bring that into REGISTER 360. And wait for it to populate. Now, some of these processes can be a little lengthy, so I'll likely pause the video at certain points here while things are loading. Loading times will vary depending on the size of the project and what was scanned. I know that this particular project is the last one that I did, so there it is, job number 4. And because I started the job on the scanner, I wasn't able to name it. If you use an iPad, you can name the job on the scanner, and then it'll actually come with a name on it. Basically, I check anything I don't want to import, and then it starts kind of populating this little thumbnail area here. And you notice it has the setups all listed, 1 through 3, and these lines started as dashed, but now they're solid. The solid lines indicates there's a registration or a link between these two setups. Now, I didn't do anything to make it do that. That was automatic. And that's the advantage that Viz technology bringing data from the field is. In previous generations of scanners, I would have to go through and do some sort of registration on these independent setups to put them all together. With the 360, I don't need to do that. It's already done for me. So I can go ahead and uncheck the automatic target or auto cloud. If I didn't have an RTC scanner, I might use some of these functions to help me register them. But in this case, I do not have to worry about it. And I'm just going to hit the big import button. Again, loading times will vary. I didn't check the size of this data set, but I imagine it's a couple gigs. Doing the images dramatically increases file size. Scans themselves are not very big, even in the high resolution. So if you're looking to make the import times faster and the data set smaller, simply just don't do the photos. Now, I'll show you what the values of the photos are here when you get the data imported and get it looked at. But for some mechanical areas, when we're just looking to compare scans to a model or come into an area that we don't maybe have plan set for and be able to do an as-built scan and then create a drawing set. Sometimes the images aren't necessarily something that we want. Sometimes they just take up space. So keep in mind that the images are a good part of the data set and can be eliminated if they're not necessary for the particular project. All right, the download process took about 10 minutes or so. So we've got the data set here. I'm going to go ahead and OK that. All right, so we'll talk about some of the tools built into the REGISTER 360 software. On the left side here, We've got our job and then kind of a subdirectory of items in the job. A project, both in the scanner and in the software, is basically a database. So anytime we make changes, change registrations, mess with setups, clean things up, it just changes the database. If you need to save anything, program were to crash at any one point, I've always got the database to go back to, so that's an inherent advantage. And the older software used to show you the kind of the database structure up front. And the newer software, one of the things I really like about it, it kind of hides that in the background, and it has this kind of graphical display that shows us everything that we need to know. Left side, we have got one bundle containing 3 scans, and these are the 3 different setups. If I click on the setup, it'll get highlighted to show me where it's at. Also, I get a little thumbnail view here. Helps me kind of look at what was about the scanner at the time. Let me orientate myself. The middle part is a map view. We've got a couple different ways that we can look at data. These scans themselves are represented by these triangles, and I can obviously select them from the map display here. The links between them are showing the registration links between the different scans. And as you can see, I've not manipulated this in any way. These scans came in pre-registered with these links already established. If I click on the bundle here, I can look at my strength of error here on the right, showing me the overlap, the cloud-to-cloud accuracy. So there is literally into the thousandths of foot of error between these. So it's very, very tight scans. Part of what makes this whole thing so powerful is the viz technology helps the scanner orientate, and then the software automatically compares things in the scans to other setups and then tightens itself down. It's really doing this kind of self-optimization, but it's doing it by millions and millions of points. That's how it's able to achieve such a tight accuracy between the different setups. So everything here is green, which is good. If my scans were a little further apart and I didn't have quite enough overlap, I would get a different color. If they were really weak, I'd get a red color, I believe is the weakest it will show. And that's simply a matter of making sure you keep your scans fairly close together, and so you can have enough overlap between them to make these connections very strong. It's a real rule of thumb. In order to do this, the room that I was in was fairly wide open, and I'll show you a kind of a bubble view of the room here. I just wanted to make sure I could get these mechanical items in the ceiling covered enough to be able to bring them into software and use them. It's just a matter of having an eye and looking around and making sure that you're covering what you want from enough different angles to be able to capture it effectively. On the map view, we've got some other options. I'll show you the True Slicer here next. This is kind of a neat tool. What the True Slicer allows me to do is basically look at anything that has a 90-degree perspective to the screen. I'm going to make the slice thinner, but I'm going to move the slice throughout the scans. And what it's doing is each color represents the scans, but it's also showing the overlap between them. If I zoom in on an area like this, where I've got all the different setups represented, the lines are very clean. And I've got a really good registration between all the scans, so I can see very clean lines between them. So True Slicer is just a way to kind of verify that the scans are indeed very tightly located to each other. The sitemap is what we have been looking at. I can click on a setup and go into it by going to the setup cloud here on the bottom. And now what I kind of enter is like a Google Street Image sort of view of the setup. So I can look around the area. And this is the power of using the images, is that now instead of a bunch of dots or a grayscale sort of display, which I do have the option to look at, I'm now seeing a color image. One of the neat parts about this HDR technology is this part of the room is fairly dark. If I go through an area that was lighter, which might just be this one over here, and I go back at that end of the room, and even this end of the room over here, they're fairly dark. But I can still click on them and look at the images. Now, this is an interesting setup here, where part of it's light, part of it's dark. If I want to lighten this up a little bit, I can jump into the HDR image and actually be able to take it and lighten it up. So I can take the data, maybe it's a bit dark, that's okay, and still be able to see some of the details in the image. Now, it only goes so far. You can tell the points are kind of seeping through on the image here in this really dark area. At least I have the ability to kind of counteract that effect and get the image to where I like it. We'll go back to one of the other setups going this way. And we'll start here. All right. And then I'll turn back to the regular image so we can look at the pictures. So that's the setup cloud. We've looked at the sitemap. Last one is the bundle cloud. The bundle cloud is just that. The scans are already tied together. Now I can look at them in a more true three-dimensional space. You can see that it's the outside of the room, or the inside of the room looking on the outside. I've got a couple of tools here for orbiting. There's a nice little tool here for fly-throughs. And I can go through an area. It's a very nice little visual tool. Really helps me navigate the scene in another way. All right. And now I'm actually inside looking at the bundle cloud. And I can switch back and forth. Everything in here is a point. It looks like a picture at this point, but if I zoom in, you can see these are just literally billions of individual points. All this data is three-dimensional. It's all measurable. If I want to do some basic measurements from this screen, I can. Straightforward. I'll grab the measurement tool, click on 2 points, and it'll give me all I want to know between them. Slope distance, height, distance X, distance Y, all that good stuff is included. So each one of these points is just a measurable piece of data. That's really what the scanner gives us, the ability to document a scene, capture this data, and be able to take measurements off it whenever we like. So I can be back in the office and know that I want to maybe know the distance between these two objects here. I can quickly just grab the measurement tool, pull that distance, and at any point along the project life, I've always got this data to go back to. All right, let's take back to the sitemap here. So about all I want to take a look at. There are a couple different ways to look at data. If I didn't have the images turned on, what I would see was what's called an intensity view, which looks like this. So really it just shows data by the intensity of the laser scanner return. So even these dark areas here, I can see very clearly where just from the image, I really couldn't. That's because the laser doesn't require light to get a return. So even though this is very dark in here, I still got, very bright colored data, so I still got great returns. So this is a good example of if you're in a really dark room, the images don't have any value, then simply turning them off will give you this view, which you can still use from. This is still three-dimensional point data. It just looks in a different way. And sometimes some objects are easier to see from intensity values than they would be from the images themselves. So things can kind of stand out sometimes by switching over to this display. Like this back wall is very colorful and different, and I can see it very clearly from the intensity. Same thing with shiny objects like these ducks up here. If I get into them, sometimes parts of them are easier to see from this view than from the color from the scanner. There's also a black and white view that takes the intensity and puts it in a grayscale sort of mode. And again, I could look at this view if I didn't do the images as part of the field work. Again, sometimes some things stand out a little bit more. I have these kind of stains in the concrete here. From the picture, I may not really notice them, but certainly from this view, they stand out because they're just different from the floor around it. We'll go back to color from the scanner. All right. We'll go ahead and finalize this. And it's a simple process. And really just, it's this little kind of workflow up here. If you follow along this, you'll generally get to where you want to be. So I hit the Finalize button. It's going to jump me back to the sitemap. It's going to ask me to accept it twice. I'm not sure why, but it does. I'll accept and then accept again. And really what it's asking me for is making sure I'm accepting this registration here. Now to publish. Included with the REGISTER360 software is this registration report. I can customize this. I can add my personal information here. I can change the logo for a company logo. I can add in any information here, site logos, all this sort of stuff can be updated. And it just kind of goes through and gives me a report on the registrations, errors between the setups. And if I had done any screen captures, I could actually add them into the report. Screen captures was part of the review process over here. Essentially, I could make this a report I can hand as part of my deliverable, saying, okay, this is the area we scanned, and this is the values of my registration. This is produced automatically. Also, the different types of data sets that we can get from the REGISTER360 software. These options down here are very standard point cloud file formats: PTS, PTG, PTX, and E57. My personal favorite is E57 because it's a pretty small file size. PTX works really well with Recap. I think that's one of the Recap standard formats that it likes to work with. If I want to create these different files, I can simply just check this. And as part of the publishing, it will automatically produce that data for me. And then I can obviously hit the three dot button over here, tell it where to save it. A couple of the Leica specific outputs are here. True View is something I could touch on in another video. It's a kind of a Google Street View that I can share with clients. It doesn't require any special software to be able to look at it. Those are views that can actually be looked at in a browser. Jetstream is a new technology for very large data sets, being able to view them in CAD environments. It also has the ability to produce a file that, again, you can look at in a viewer for free. So Jetstream is a kind of a newer file format with Leica, and gives us the ability to produce data in a more compressed format that, again, can have some more compatibility, especially in a CAD format. That's really where it has its value. This newer file here is going to be an interesting one, and this is actually what we're going to be producing for the next step of the video, is the LGS file. This is new with Leica. This is a file that basically is going to be a standard across all the platforms. This LGS file could be read into anything that Leica produces. And part of what Leica produces is an add-on that will be in our next video called CloudWorks. And CloudWorks is an add-on for a variety of different CAD programs, Revit, Civil 3D, and also Navisworks, that you can take these scan data and bring them into that environment and actually do some manipulation directly in a CAD environment. Most of the newer AutoCADs support point clouds to a degree, but their use is very limited. Meaning they don't allow you to bring in a lot of point cloud points. I think most of them max out at 1 million or 500,000 points. Where this data sets, get into the hundreds of millions, and it just wouldn't work. So these Leica add-ons give us the ability to use the same engine that we're using to view data here, but in an AutoCAD environment. And they're really well recommended for bringing data and be able to look at it in an environment you're already modeling in. Some uses for the data sets could be bringing into an established BIM model and do verification. Do these points match the model? Do I need to change things around? So for either verification or maybe even a quality control standpoint, being able to bring in this data and overlay it on top of an existing 3D model is very beneficial. Also, the ability to create data. I can bring this into a CAD environment. I can produce drawings from it. I can produce a model from it. Most tools are becoming more advanced all the time. Things like pipes and ducts and those sort of regular structures can be pretty easily modeled from the point cloud. That's part of what I will go over in the next set of videos. There's a little bit more on that. But I wanted to get to this point where we could get from the field to a format where we can start looking and creating deliverables. When I'm ready, and again, the LGS file is what I would select here, and then I would give it a name and tell it where to put it. In this case, I will put everything on my external drive. Now, these data sets can get rather large. Definitely thinking about storage is going to be important. I don't have a folder for this data set, so I'll just start creating it here. Now, this data set is separate from the REGISTER360 project. And again, the REGISTER360 is just to get me to this point where I can start getting data organized and together and into a design package. Right, and you want to hit publish. It's going to put it in this particular folder. And again, this process will take probably about 15 to 20 minutes to produce this data set. So I plan to do another video. On request was compatibility with Navisworks. So my plan is to load up a demo copy of Navisworks, add the CloudWorks license I have to it, and then be able to bring this data set into a Navis environment. If you have any questions, feel free to call me. Thank you.